The sponsor of this project was USAMR. The project was a lift and rotate mechanism for an autonomous mobile robot. The Grand Valley students who worked on this project were Sean Madralejo, Austin Breen, Evan Yasik, Nicholas Rizawa, and Riley Dillon. The purpose of this project was to design and manufacture a lift and rotate mechanism to bolt into an autonomous mobile robot. USAMR is using these mobile robots to locate shelves on warehouse floors and relocating them. The mechanism must withhold 1,500 kilograms, lift in 3 seconds, and rotate in 90-degree increments in an additional 3 seconds. The mechanism had to stay inside the given bounding box with a budget of $4,500. In light blue is a bounding box that USAMR provided the team. Highlighted in this photo is the safety guard for lifting and raising. The aluminum engagement plate is the topmost part on the assembly with a cutout in the center. This was so USAMR could place a camera in the center of the mechanism. A wear ring was used so that the steel cam rollers don't wear away at the aluminum engagement plate. The cam rollers help provide support near the outer diameter of the middle plate. A bearing in the center of the mechanism was used to provide rotation, which is connected to a gear underneath. The gear pictured in this photo was strategically picked out to handle torque that would be seen from 1,500 kilograms. The motor driving the second gear, both picked based on torque calculations and datasheets. An encoder was used to give a precise positioning of the angle in which the plate has turned. A camera mount and camera were placed in the model to locate a space for USAMR to mount their barcode reader. Guide rails were designed to support any tilting or swinging action during movement. The mode of vertical movement for lift was chosen as scissor links. The force that these links face is large, and this was a big challenge that we faced due to the size of the bounding box. If there was more room, the links could have been designed larger. The extension bars from the actuator were attached to the actuator and both sides of the scissor links to lessen chance of binding and so both scissors moving at the same rate. Limit switches were used to locate the distance traveled on the rails so that the plate is lifting 50 millimeters and lowering 50 millimeters. An electrical actuator was used to power the movement due to the fact that the sponsor was trying to stay away from hydraulics and pneumatics. Lastly, the base plate was made out of steel and cut in half for ease of manufacturing.